Hi, it's Richard here from Past That Science. Just a quick one today about undervoltage protection, what undervoltage protection is and how it is afforded in a direct online starter. Undervoltage protection is probably better explained using a scenario. Imagine, if you will, there's someone using a lathe or a mill or a heavy machine or something like that that's being driven by an electric motor. And then all of a sudden there's a power cut and all the lights go out and all the machines then stop. Now, what if then, while the power is out, the operative of the machine then decides that they're going to clean it? They've been meaning to do it for some time, so they decide to get into that machine and start cleaning all the swarf and the oil and all the muck out and everything like that. And then suddenly the power comes back on. What do we not want to happen? Now, what's the risks that's going to be involved? You've got the guy with his hands in the machine and then suddenly the power comes back on. Now, clearly there's a danger there. Protection is where we're going to prevent the automatic restarting of machines in the event of a power failure. So if you imagine, if the power goes off, what we don't want to happen sometimes is for the machine to automatically restart. Now certainly then, if the guy is working in his lathe or his machine, he doesn't want that to restart while his hands are all in it. So undervoltage protection is a requirement of BS 7671, which says, except where failure to start after a brief interruption would be likely to cause greater danger, every motor shall be provided with means to protect automatic restarting after a stoppage due to a drop in voltage or failure of supply, where unexpected restarting of the motor might cause danger. So there is a danger in that scenario. The guy's got his hands in the machine. We don't want that motor to restart, so therefore we need to have undervoltage protection. It is to prevent the automatic restarting of machines in the event of a power failure. Direct online starter. Now these things exist because they have lots of different functions. These are very, very common, this type of starter, and the reason why they exist is because they can provide what they call functional switching for non-electrically skilled or instructed persons. So anyone can just use this to operate that motor with the start and the stop buttons. It has a degree of overload protection for the motor, and it also provides undervoltage protection because of the components that are in it and the way that they're configured. So we're going to be having a look at that. Main components to a direct online starter. We have the contactor, which is that part there, the thermal overload, which is this part here. Now the contactor, what that is basically, it's a kind of an electrically operated switch. You have contacts inside this contactor here that look like that. The contacts are quite heavy contacts, they can pull large amounts of current. And we also have an additional set of contacts on the end there. That is what we call the auxiliary or the hold-on contact. Now these contacts there, they're operated by an electromagnet, which is in the form of a coil. So you'll hear it being referred to as a coil, and when you energize the coil, it will then bring those contacts together. And that is then, the coil itself is controlled by a control circuit, which we'll have a look at next. Control circuit. So what you have here at the top here, this is where your electricity supply is, and that's where the control circuit is connected. Sometimes it will have a protective device, sometimes it won't. And the supply, as you can then see, it goes from the supply to that thermal overload relay. Now inside the relay there is a normally closed contact. In other words, it's connected until a point where if there is an overload, it will then disconnect that part of the circuit. So in normal use, the current will flow through that thermal overload down through the stop button. Now the stop button again is a normally closed switch, so that when you operate the stop button, it opens and disconnects the circuit. But in this case, the current will flow through the stop button. It will then get connected to the start button. So the start button is a normally open switch, and when you press that start button, it will then make or close that connection, which will then energize that electromagnet. When it energizes that electromagnet, that will also cause the auxiliary contact there to close. And the idea of that is so that when you then release the start button to walk away and work on that machine or whatever, the electricity supply will be running through that auxiliary contact. And then since the auxiliary contact is keeping the coil energized, the coil, the magnetism there is keeping the auxiliary contact energized or closed, so that will keep the supply running through that electromagnet, and you can just carry on and work on that machine until such times as you press the stop button. Power failure, of course, then the electromagnet will de-energize and the magnetism will drop out, and then that auxiliary contact will then be opened. Okay, it'll break the circuit, and that part there will be open. And so what it means, of course, then on a power failure, there will be no path for the current to take. If it was re-energized, okay, it would go through the thermal overload, it would go through your stop button, but there's no path now for it to go through to the electromagnet. Now, in order for there to be a path through to the magnet, we're going to have to manually push the start button, which then means, of course, we haven't got any means of automatic restarting of this machine. It's not going to keep going by itself when the power comes back on. There's no path through the auxiliary circuit or through the start button. We have to then start it manually by pressing the start button. So we've avoided the automatic restarting of that machine, and therefore we have achieved under voltage protection. So it's this arrangement here with the coil and the hold on or auxiliary contact that gives you that under voltage protection. When the coil de-energizes, it opens the auxiliary or hold on contact, and then the motor stops, and it's not going to restart until you manually press the start button again. When there is a drop in voltage, maybe a power supply, power failure, then the electromagnet or the coil will de-energize, and the auxiliary or the hold-on contact will open, which will disconnect the coil from that source of supply, so that when the supply comes back on, it's not going to automatically restart. And therefore, that's provided us with under voltage protection. Now, go past that science.